Hi. On my first presentation, so I might be a bit rusty, but let's go with it. At the beginning, there was CRUD. We're all doing CRUD, we all love CRUD, and we will hate CRUD. It's nice, it's simple, it's very straightforward in developing. And what CRUD is really about is about state. With CRUD, we are operating directly on the state of the application, which we usually storing in database. And what we do is changing it directly. We're using different things to avoid problems like locking transactions. But at the end, all we do is work on one big state. To make it simpler, we come first to command query separation. It's not CQRS yet. It's about splitting your logic into two sides. One side, which is changing the data or creating them, and second side, query, which is just reading them without any change. Let's start with command, which is the part of your application which does the change. With the naming, you want to be explicit, because when you're doing, in comparison to CRUD, CRUD is about creating and updating and deleting. With command, we are more explicit about intent, because in our applications, we are not creating records in database. We are not updating them. Usually, we're performing some specific business process. Let it be registration of the customer. It's registration, as the Marco said with modeling. It's about registration. It's not about user creation, because we can have system where customer can be added by hand from the admin panel, can be invited by another customer, and those are three places where in the traditional CRUD application you would have a lot of ifs to check all the variables, and you would get one big record with logic everywhere. With commands, you would have three command handlers, which would encapsulate specifics of each operation. Because when I'm registering as customer, I will probably want to get email. If I'm added to the system by hand through admin panel, I probably don't want to get registration email, or communication will be different. With this in mind, at this point, we are still at the back. We are operating on the same state we had in the CRUD. All we do, we are just extracting our logic into specifically named pieces of code, which shows the intention straight away. With that, we are getting a lot of flexibility, and when we're talking with business about changing registration process, we know exactly where this piece of code will sit. Other thing are query. Queries are, I would say, less important at this part, because they are not changing the system. Of course, there will be some changes like pagination, etc., etc. But when we have this one state, one model, we can also model query in the way we will have different representation of the object. So having queries on separate side, we have also freedom, because changing domain object on the command side, changing model on one side, don't need to say that we will change the query side as well. Again, with the customer data, there will be different representation, for example, for admin panel, but user won't see list of all the other users, customers. also won't see like private flags, system flags about himself in the system. And this thing is first step into better world, where instead of having CRUD, direct operations, we encapsulated them into specific pieces of code, and we can work with this way easier. In real world, as a few companies ago, I used exact this style to create APIs. There was no event sourcing, etc., just working on state, just creating commands and command handlers. In practice, building APIs or forms, it doesn't really matter. Command itself is just pojo, popo, dump object with getters and setters, maybe just getters. Then we have command handler, which is this piece of business logic I talked about, which handles one command. There is direction one-to-one. Each command has one command handler. Response can be returned. It's kind of, again, against CQRS. It's ask instead of tell, but it's very helpful. In the matter, when you're building application, you usually have some input and some output. And using commands, command handlers, you can encapsulate input, whatever it is, encapsulate your output, also whatever it is, and have your business logic in one place. And this code will become very mobile. As Marco said, you need to just implement how requests are created, how response is serialized or presented to the end user, and this will also speed up your development, because you creating one handler per feature allows you also to deliver one feature encapsulated code and go on with it. Yes, state change only inside the handlers. Using this architecture, you need to be completely sure that you're not changing state in other parts of the system, because this can lead you to like things changing unexpectedly. Command reflects one thing to do. In other case, we had creating investment, and naming by the business process, how business people calling the thing you're doing is also very important, because even in chat over the beer on Friday, you can hear people talking about your code, and you can easier find out edge cases or changes that, okay, this shouldn't be done this way. Another benefit is when interaction changes, you have only one place in the code which will change, and you can very easily avoid very nasty regressions. Because with traditional CRUD, if you had a lot of ifs, you need to check all the paths in your code to be sure that everything is working fine. With changing to only one command handler, you have probably unit tests all around, and you can catch regressions very fast. And yeah, who cares about queries? They are not changing state of the system, so personally in this implementation I'm using straight repositories in the controller if it's possible, because this part of the system can be done way simpler to save some time. Because what we really want to focus is the command part, where the business logic happens, not on the simple read operation. We can add some modeling on this side, but yeah, if you want, you can play. I think there is more value on the properly creating command side than query side. But of course, we need to find the middle ground and do all things good. So let's add the missing R from CQRS. CQRS talks about separation on a bit deeper level, where we have separation not only on the business logic side, but also on the model side. So we are splitting basically application into two databases, write database and read database. Event sourcing is one thing, but let's start first with write model. Write model are your entities your business logic works on. This is representation optimized for change, which encapsulates all the behavior of your application, which affects in changes to the whole system. While read model is all about reading, all about those queries, where you can shape the data in the way you really want, instead of having countless joins and mixing all data you probably don't need in views you're creating. You probably saw all the APIs where you need to exclude on the serialization time. You need to mark some fields as excluded in serializer, etc., etc. Instead of that, you can create a read model which shows directly what you want to present. You may ask why. Why to separate both sides? As I said, first point is you can prepare data for many different views, and I'm not even talking about just serialization, but view of the data is different for specific users, specific actors in the system. End user sees his data differently than report for the business shows data about users. Transformation, I think I skipped. Write model is where the change happens, and after the change, the data are transformed into read model, so we are keep it in sync. And this transformation can be very important, for example, in e-commerce system, where, for example, in Magento, you have very lovely EAV model of product, entity attribute value pattern, where you have a lot of tables which are unsearchable, basically, and you probably need some search. And this is your write model optimized for write, because you want to operate on many attributes of the products, and this is good. But for reading, you probably want something like, I don't know, Elasticsearch, Mongo, where you can create document of the product with all the fields which you can search. And this is the separation, where one thing is optimized for writing, another for reading. And data are also more readable on the console level, where you can just search product and you see all the data in one go. As the transformation from write model to read happens, we can treat it as integration with other systems, where we notify other systems about changes in our write model. For example, we need to send compliance email when user changes his email or address. And during this transformation, we can look for the specific things which are changing and react accordingly, instead of endless if statement in traditional way. Another thing is also performance. As we are doing transformation, we can shape our data as we want, and instead of having joins through whole database, we can create just one table with one-to-one with the reporting system, where at the end we have just select star from table, and this is a simple query. So let's talk about what happened. We are transforming data, and the event sourcing is about what happened. Because when the write operation is performed, we know that everything was fine, everything was validated, all the business rules were met. With that, we can say that something happened, event happened. And event is description of the fact from the past. From the past, not of the past. How to say it? User registration again. The form create event, for example, user registered. And this is very specific event which already happened in the past. And we can react on this event to create views or integrate with other systems, send emails. We have all the data there. Command is a command. Command and command handlers working similar way. They are simply used instead of changing the state, current state of application like in CQRS architecture. Now they are made to generate events. After all the validation, all the business logic happens in command handler, there, instead of saving the state, the events are generated. And this is the way from command to the event, no state change. All we know that something happened. User registered, product was modified, parameter was added to the product. And events can be added, but they cannot be modified. We cannot modify facts, we cannot modify pasts like in real life. That's why with event sourcing, events can only be added, and the storage is simply list of events in context of the domain object the event happened with. This leads us to append only data storage. For example, like Cassandra is very fast for that. Having that, we don't have update operation. We have change specific field. It's basically your choice how granular you want to go with those kind of events. And from there, we're coming to the query side with materialized views, which are this is the query side which is generated in reaction to the event. Each materialized view, for example, user report, will have user report listener, which reacts to specific user events happening in the system. When user registered, when user registered event happens, this materialized view listener will catch the change and will add new row. Here we are operating on the state like in the other way, like in the CRUD way. Here, if you want to go fast, like use JPA or doctrine, just create new objects, because here you are based on the state. Only the difference is that you're changing the state based on the event, which you saved on the one side, instead of changing the state directly. And you can have as many listeners for specific events you want, with as many materialized view you want in any storage you can imagine. And having this append only history of what happened allows you to do few interesting things. One thing is that you can replay the events. Let's say you have history of all the facts which happened in your application over many years, and now you're getting requirements that you need new report based on the data. Having only current state of application, you simply need to start collecting new data from the scratch. Report builds very slowly in time. And basically the start of the reporting is when you deploy the new feature. Having history of all the events which happened in the application over time allows you to replay all the events over the new listener and create reports on stuff which happened very long time ago. Another thing, you can change the dimensions of how you reporting things. Because we are talking about state, about the data we are saving, but there is also a lot of metadata included into the whole thing. When the event happened, who it happened with. And having only state, for example, you wouldn't be able to create report about like sales difference between Friday and Monday, or how many items were added to basket on Friday, how many items were added on Monday, what is the difference. With this and replayability, you can check which events are happening more often at the given time. You can also, next thing, you can undo things. As we said, replayability is a list of events happening. If you remove the top event and replay things again, you will go back in time. Saying that it's append only database, but based on the last event, you can create a reversing event if it's needed in your system. Because you have only one atomic change which happened, and it's way easier to control it on the event side than having like versioning over SQL where you have endless rows of the copy of the data, because this is the way to do in normal relational databases. Next is audit trail. I don't know if you work in finance, but this is kind of important thing to know where money is going, and having all the events stored, and someone asks what happened 10 years ago, you have your answer straight in front of you. And it also helps with, I called it reactive system modeling, but in microservice architecture, we are talking about many services holding a lot of data. And having our product database, we can say that we want to get information about product, we need to create REST call to get data about this. But what we really need is ID and maybe SKU. But we need to do REST call. What we can do is to duplicate the data in other service and use event bus to distribute the event which happened in one service into other services and update the local cached representation of the data we are interested in. Same with users. Most of the backend admin side, back office side services, they don't need information about user password. About password salt, we don't need even like expose it to them. All we need is email, first name and last name. And the representation from the domain perspective also changes. And we can keep as many models, as many representations of our entities as we want. All we need to do is just react to the event and update our local state of the application we are working with. But with all the good things, all the upsides, there are also quite a lot of downsides. Because CQRS, as nice it is, it's quite complicated and heavy thing, which is kind of hard to introduce, especially if you have big legacy code base. You can use, assuming you have SQL database, you can use tools like Debezium to simulate this thing. where you have events created based on the database changes. This is basically, it depends on your code base, is basically one point where you can create those kind of events. Not on code level, but on the database level. It's based on binary log. And then you can slowly migrate from the database generated events to normal events. It's also, I would say, a bit slower sometimes to work with, to develop, because you need to take greater care into how you structurize your events. It's also infrastructure heavy, because you need 2 databases instead of 1, and probably you want something like Kafka or RabbitMQ to distribute events if you're working with multiple systems. And when it comes to events, another downside, tricky thing is when event changes. Because in time you will get new features, new fields in your entities, and either new events will happen, or you will need to change the existing events. And ACID system will work correctly to be able to replay the old serialized event where the entity doesn't exist. You need to create transformation layer which will adapt the events, the serialized versions of the events, into new objects where some fields may be null and behavior may be unexpected. Yes, so yeah. In summary, CQRS is about separating things which are changing the state of your application from the part where you're just presenting data. And event sourcing at this part is the part where you're saving data as an event. You're saving facts which happened, and then transforming those data into view. And this is the command query segregation, responsibility segregation. Yes, and that's all. Thank you.